Welcome, everyone. I'm very excited today for this topic. As we know, ML is quite topical. Today, we're going to be delving into SRE for ML, aka MLOps. We're going to be doing a travel to the past, look at the last 10 years, and then reflect towards the next 10 years. Before I start, I want to actually get a couple of hands in the air with a few questions. So raise your hand if you have operated an application in production, any application. Okay, so that's pretty much everyone. And now raise your hand if you've operated an ML application in production. Okay, so that's maybe about 15–20%, so that's a good chunk. Great, so that gives me a good calibration. What we're going to be delving into today is the latter, and more specifically how it is different for the former. So a bit about myself. So as Henrik mentioned, I am director at Zalando, European e-commerce. I am also board member at the ACM and AI expert at the UN. So we're going to do today a journey to the past and the future. And obviously, we are also going to do this with the help of some AI itself. So what we're going to be covering is just an overview of the motivations, why should we care? A reminder of the foundations, right, for the other 80% of the room that maybe actually be introduced to some of the key topics. And then we're going to talk about the different parts and stages of the MLOps history, let's say, but from a perspective that would then resonate with this round. Then we're going to actually see and try to do some predictions for the next 10 years. And then we're going to reflect on those. So let's get started with the motivations. So we know AI is big, right? Last year I presented this number. It was about 500 billion. So this year is 757 billion, right? So it continues to grow. And indeed, it's a projected 5x increase with almost and over 100 million individuals in the field of AI, in the workspace of AI. And this includes, obviously, not just software developers, but perhaps it could be broader than that. There are actually some success stories, right? So it's not all just hype. We've seen that especially people that are building the pickaxes have been able to generate some momentum in the gold rush. So GitHub Copilot with over 300 million annual recurrent revenue, Adobe with another B2B tool with 1 billion in ARR. And of course, what we have to also be considerate is that the hype is also continuing to drive a lot of the momentum, right, with some of the consulting firms cashing in on purely just consultations for GenAI. So the key thing today is also how do we capture the hype and not just stay in, how do we capture value and not just stay in the hype. Some of the use cases that we see in industry, so this is also within Zalando. We actually use AI and have been using it for the last many, many years. So this includes use cases across search recommendations, price optimization, size and fit, marketing, GenAI content. So whenever you have interacted with this e-commerce website, you likely have basically interfaced with an AI system. And with that, basically, that means that you've interacted with a hopefully reliable AI system. Now, the opportunity within MLOps is huge, right? There is an acceleration that organizations are identifying, and they can actually figure out that if you can precisely and efficiently capture the value of AI, you can really drive a lot of acceleration and value. And this opportunity is not just linear, right? It's a muscle that you strengthen, right? And this is to be able to continuously deliver AI capabilities and AI innovations. And it is many of the members in this room that will be actually responsible for driving some of those capabilities that deliver the value continuously, similar to how it has happened in the software field, right? With things like continuous delivery, etc., continuous deployment. So with the motivations, I think we all know why we should care, right? Now, let's remember, what are some of the foundations to know how is ML different to traditional software? So let's go back to the basics, right? With machine learning, you start with data. You then are able to train a machine learning model, right? You get a model to learn from data, right? And then you iterate, right? Until you get to a specific accuracy or performance metric that you desire. Once you're happy with that, that model is ready, and you have to persist the model, the code, the configuration, and then you can use that model for quote-unquote production, right? You can actually run new unseen data through that model. This could be, for example, recommendations on a website, right? Like you first have to train the model offline, right? And then once it's ready, you make it available, right? And from that, you see some of the inference results, right? This is when you actually go into a page. That's when you get maybe the results. And this is for any type or large number of machine learning model use cases. Obviously, you have other types like reinforcement learning, et cetera, that is a bit more nuanced. But at the same time, this should give us enough intuition. Now, the life cycle of the model, we thought initially that it finishes once it's trained, right? Like we have a model, we can use it, we put it in production. It must be like software, right? Somebody wrote this Fortran program in the 70s, it's still running, nobody touches it, it's still working, right? But with ML, it's not the case, right? Once the model is trained, once the model is deployed, maybe you find that there are outliers or that there's actually a drift, right? Perhaps the actual environment has shifted. The behavior is different. So now your model has in a way deteriorated or even expired, right? So from that perspective, you have to continuously be able to understand when your model stops being good. And that is a very, very hard question. It's not just monitoring for telemetrics, like telemetry, but it's actually going beyond into the use case itself, right? So the life cycle of a model only begins once it's in production. Now, the challenges go well beyond just that. So compared to traditional software, there is a significantly larger consideration when it comes, say, in the orchestration, right? When you have machine learning models, they may require a significant amount of RAM capabilities, or perhaps multi-core CPUs, or GPUs, or specialized TPUs. Or significant amounts of storage, right? Yes, you may think to yourself, well, but I know this application, this software where I needed to do this, I had this out-of-memory error, but in this case, it's the norm, right? It's not the outlier. A significant part, you have to deal with this complex orchestration. You also have complex data flows, and these data flows may consist of synchronous and asynchronous interfaces. Something goes wrong, you then may have impact up the stream, down the stream, perhaps in a few days, perhaps in a few weeks, right? So this is something that actually requires a lot of consideration. And the last one is that reproducibility, right? If you have basically the code, right? Often if you have the environment, you can actually rerun it. When it comes to the machine learning models, it is not the case. For starters, in some cases, it's non-deterministic, right? Probabilistic systems may also have different behaviors, but also you require the artifacts, as well as the environment, as well as the servers themselves. And we're going to dive into a little bit more detail on what that means. Now, let's get started first with the past. Let's rewind back, not to the 80s, right? Because there was no MLOps back then, but back to the 2015s, to the genesis of MLOps. Then we're going to dive into the next chapter, which is the messy innovation. So that's how I categorized it. And then finally, in the last 2 years, being the LLM ops era. Very hard to pronounce, but I got it. So one thing that is interesting as well is that if you had asked me back in 2015, what is my prediction for the next 10 years, I would have put all my money that MLOps would have been solved by 2025. Right? We would have had one end-to-end machine learning, end-to-end platform that basically solves monitoring, serving is already done, and we would just be able to continuously deliver and deploy multiple times a day, right? Fast forward to today, not the case, right? So let's get started first with the genesis, 2015 to 2017. So let's get started where it all got started, which is with this paper from Google called The Hidden Technical Debt in Machine Learning Systems. If anyone in this room has been in a talk around MLOps, you have probably seen this diagram, right? This is just basically the logo, the poster child of MLOps. It basically just says your ML model is a tiny, tiny speck of the sand over there. What you actually require to run efficiently your models is the entire thing around it, right? And this was actually mind blown, right? Wow, I didn't realize that, but it was really in our face. And this is where we could actually trace it back. The word MLOps wasn't actually referenced there, but this is where the taxonomy of challenges started emerging, right? So things like data dependencies, unstable signals, hidden feedback loops, configuration debt, entanglement, et cetera, et cetera. Then on 2015 to 2017, we saw actually a pretty interesting scale with the big titans, the big tech, just publishing their own machine learning platforms. And before that, the way that it worked was data scientists train the models on laptops and engineers re-implement them, right? They write them in Python, they write them in R, and then suddenly the engineers rewrite them in Java, right? Now, Uber's, and actually to mention, this is still the case today, by the way, a lot of the times, unfortunately. But the platform that actually set the scene, and one of the most renowned platforms back then, and that still is quoted, is Uber's Michelangelo. So this came to life actually providing hope, right? Like, wow, you can actually have an end-to-end machine learning operation platform. And not only that, but they were able to introduce some complex components, like, for example, the concept of feature stores. I mean, we're going to dive maybe into a little bit of detail. The concept of bridging real-time and batch, right? This is another consideration. And we saw that with, for example, Flink, right? That was back in the day when we were seeing kind of like some attempts to do that, right? And on top of that, also bridging it now to this day into Gen AI. Now, this release also followed with other core platforms like SageMaker, right? You may have heard of that from AWS, Facebook Learner Flow, and TFX, right? So that's back in the day when TensorFlow was a big thing. Now, as part of this, what is interesting is one of my focuses back then was to actually start mapping the, I guess, wild, wild west and trying to make sense on what could be this architectural blueprint that we can align towards. That's also when I founded the Institute for Ethical AI. So that's when we started actually looking at responsible AI. And one of the first efforts was really, what does the architectural blueprint of MLOps look like, right? And this is what the hypothesis seemed. So you have basically 3 stateful areas, right? Your training data, your artifact store, and your inference data, right? So in the middle, basically, this is where you have your trained models. So the way that you have the workflow, you have scientists experimenting in a Jupyter notebook, right? And they are basically exploring, creating from training data, trained models, right? Obviously, they may also use platforms for hyperparameter training, tuning, training, evaluation, etc. Then ideally, you may also have some automated way of getting your models to production, right? Some CI/CD, analogous to the developer ecosystem, that gets basically the server that runs it and your artifact that basically puts that model in production. And then you have some monitoring on top, right? This could be traditional monitoring or advanced monitoring. And once you actually have your models in production, you have inference data and you have a loop that goes back, right? So this is basically the architectural blueprints, right, that we ended up reasoning about. And maybe hold this in the back of your mind, because we're going to be referencing this as well. And obviously the metadata that flows. Now, in 2017, we also started to see the emergence of flawed ML, right? So basically, bad practices and surprises of, incidents of machine learning in production gone wrong. And people were shocked. Oh my God, right? It's like connecting your ML model, deploying a notebook in production, deploying without monitoring is not a good thing. Who would have known, right? But it was also hard to be able to do the mapping between some of the scientific concepts like model artifacts, which are binaries sometimes, the access to the models themselves, that they can be reverse engineered, the dependencies, which can actually have supply chain vulnerabilities, the code vulnerabilities themselves, the infrastructure. So it was basically scientists building production, right, without the understanding of how even the software engineering would come in to support. That's also where we started a couple of groups to explore this. The Machine Learning Security Committee, which I also kicked off in the Linux Foundation. So that allowed us to also explore some of those type of topics. So those are some of the considerations. Now, that is basically where the genesis is. Now let's see what happened on this next stage, the messy innovation. And I have to say, this messy innovation part, for me, was one of the most fun stages of I guess development and open source development, and I'll talk a little bit of why. So this is how it started, right? The machine learning ecosystem back in 2016, 2017. If you had seen it, it would look more or less like this. Fast forward, how it's going, right? And this is 2021, right? So you can imagine how much more it has exploded. And the interesting thing is messy innovation is when also it peaked on heterogeneity, right? It then moved into consolidation, and that's what we're going to talk about in a bit. So there were some actually major milestones in the field during these dates. So this included basically some of the big players releasing frameworks that established some areas. Machine learning experimentation, you need it because otherwise scientists, every time that they run an experiment, they would otherwise put it on a spreadsheet and they would track it on a spreadsheet. And, that makes me sad, right? So instead, you basically introduce automated ways in terms of capturing those metrics. Understanding, is your model number 10,033 better in accuracy than your model 11,044, right? You don't want to do that in a spreadsheet. There were other players like weights and biases, and then there was also the area of orchestration, so batch orchestration. And this was actually seen with many other players like Netflix releasing Metaflow, Ray, Prefect, Flight that were trying to tackle this. And then it also came on this concept of the end-to-end machine learning platforms. Can we get either a best of breed or a unified MLOps platform? Should we combine different tooling, or should we just bring together basically like one single vendor that does it all, right? And with that, we actually saw the rise of Kubeflow, this tool that actually attempted to do basically like all of the things, and a lot of really interesting projects kicked off. So it was very interesting to be part of that, right? Especially as so many different, almost similar projects like came out. And one of the areas that I was most actively involved was the area of real-time machine learning model serving, right? And as part of this is the realization that actually machine learning real-time microservices are very different to traditional services, right? The reason why is because indeed they are by definition not just stateful, but the artifacts themselves may introduce a significant level of undeterministic dependency. They may also have different modalities, right? It may be real-time, async, semi-real-time, batch. It would also require having basically different types of metrics and tracing to the ones that you would have in traditional services. So as part of that, the race to model serving began, right? And as part of that, we built one of those components. It was also really, really fun, right? Because it was basically abstracting machine learning concepts into Kubernetes CRDs. And back then, Kubernetes was also not super, super mature, right? Every single version, it was like, oh, we're breaking your APIs, and we have to do a massive migration on that, right? But it was very interesting to think about, hey, what does it mean to have a machine learning model as a Kubernetes abstraction? What does it mean to have an explainer or a drift detector as a CRD? Right? And what is the relationship between the control plane and the data plane in the context of machine learning models, right? So that was actually really, really interesting. And it also raised a lot of interesting questions, around challenges. So with basically the concept of machine learning model serving, you may also have situations where you don't just serve one massive model, right? Like one machine learning model that is 20 gigabytes. You may actually have a situation where you're serving 10,000 models, which are 2 megabytes, right? And you don't want to have the overhead, the massive overhead of the huge image, right, running 10,000 times. Actually, we ran into the limitations of number of pods that can run per node on Kubernetes, right? So we also needed to think about how do you introduce the concept of multi-model serving. And this is basically thinking about the concept of building a scheduler on top of the Kubernetes scheduler, right? So complicated, right? And fun, right? It was also very fun. Things like also API protocols. You have different models that are coming in and out, right? And with that, you have different APIs. Is it /predict, /inference, /infer, /model? Which one is it, right? Like every microservice that you interact with, you have a different perspective. And you also have to deal with the semantics. Is it an image modality? Is it a text modality? How do you monitor that stuff, right? And we're going to basically dive into the monitoring. So yes, the second one that was also very interesting that I was quite involved in was the machine learning monitoring. So this one is interesting, right? And this will resonate, right? So this is good old Jaeger, right? Back in the day, right? So in this case, right, with machine learning models, you have all the complexities that you have with traditional software, right? You have to actually understand what is your throughput, if you have basically perhaps memory leaks, right? You want to also understand, different metrics that are just like performance metrics, like your traces. However, you have also more considerations. You have to understand what is the actual machine learning performance, right? We're talking accuracy, precision, recall, right? And accuracy you have to compare with, base truth, right? How do you actually collect base truth in production, right? In production, you don't have label data. You just have data you've never seen, right? So you have to think about, like, what does it mean to introduce this type of stateful nature in those areas. You then also have the concept of explainability, right? You're putting in production black box models, and you want to understand, why did that model predict what it predicted, right? And obviously there's explainability techniques, but then when you deploy that, right, you're saying like, oh, I'm going to reduce the risk by putting an explainability technique in production, but what you've just done is you've just put a model in production to reduce your risk of your model in production, right? So you're basically having to also think about the governance of your governance, right? And then you also have advanced monitoring. Things like drift detection, outlier detection are key within machine learning. And you also, again, need to understand the semantics of the data that is flowing. A drift detector for text is very different than a drift detector for image, than for tabular, than for etc. So new players started to emerge, right? So we started to see, different innovations, things like Fiddler, Evidently AI, Arise, White Labs, and some of them started actually then consolidating towards the right paths. This is one of the things that I was mentioning as well, that this allowed us to also explore the architectural patterns, right? Understanding how to abstract concepts into architectural components, right? And actually, if you're interested, check the footnotes. One of them is a blog post that I published back in 2019, 2020, on different architectural patterns for machine learning monitoring in Kubernetes that are still true today. So with that, now we come into 2020. There was an unexpected accelerator. Can anyone guess what was that unexpected accelerator in 2020? It was COVID. Yes, the COVID pandemic kicks in. Remote working starts in fashion again. And then what we saw was a wave of hyper productivity in at least the open source machine learning. We saw open core companies popping up and right and center. I mean, I thought that was like the golden era also of open core, right? There were like huge investments in infrastructure tooling for open source, particularly for MLOps. We saw a lot of players just getting a lot of traction. And really, it was just like a chance where you just didn't go into the office and you had all day to code, right? So, even as a leader in the space, you just, meetings just disappear. So we saw a huge acceleration also in the adoption of players, right? Like e-commerce companies just started seeing that everything was going digital. They saw a massive surge. The investment on AI was just like, also exploding. And that really led into a huge need into MLOps. That really sparked kind of like the solidification of the field. And I would say it accelerated by a couple of years, right? Like by at least maybe like 6 years. So this was a very, very exciting time, and that actually kicked off the next section of the messy innovation, which is basically the solidification of the domain, right? So until 2022, we actually started seeing that MLOps was now a known term, right? Like it wasn't like as unknown when we started using it back in 2017. People didn't know how to refer to it. Now actually we started hiring our first MLOps engineers, back in 2020-ish. So we started seeing actually organizations really take this serious. Similarly, we saw some of the advanced topics starting to be explored, right? Intersections like MLSecOps, like safety, alignment, responsible AI. So this is also when the institute that I had established, the Institute for Ethical AI, started getting a lot of traction, right? Like a lot of really tangible initiatives that we're translating into practical tooling and use cases. And this is where we actually saw a new comet, right? The Gen AI comet of LLMOps. This is obviously in 2022 when GPT-2 was released. And one thing that I want to say, right, back in 2022, I want to claim, I remember I had at a PyCon, EuroSciPy, at the EuroSciPy, I showcased a live demo where I connected GPT-2 to an image generation model to basically create what I call the first agentic system, right? It probably wasn't, but I'd like to think that it was one of the early agentic systems, back then. Super rudimentary, of course. And that takes us to the last 2 years, the LLM ops era. So as part of this era, many argue it's different. I argue it's not. It's just basically renaming things that have existed for a long time for no apparent reason, maybe just hype, right? But it's still the same foundations, right? And we're kind of like running in circles to figure out, oh, we already knew that, so we're gonna actually go and do it. But what has changed actually is that indeed, when we have machine learning models connected to a system, we've actually changed the focus from the training-centric focus, which is basically we get the training, the batch, inference, et cetera, into an inference-centric, right? So the models are already available, right? So now we build the applications. And the interesting thing here is that out of all of the topics that I covered, the more mature ones were the training ones, right? When it comes to inference and when it comes to monitoring, we'll talk a little bit about in a bit, those are the components that are actually the less mature. And this has flipped the entire script to just go full into the least mature part of MLOps. And this is probably why we're seeing so much heterogeneity and lack of standardization, because we were still trying to figure it out. And now this is pretty much just accelerating it. It also is changing the economic model, right? We're starting to see this concept of not just human in the loop, but AI in the loop, right? People connecting things to systems that they shouldn't, right? People just forgetting about like the basics of software security, right? Or acting like they forgot, right? Because they just want to run a POC. And also the emergence of new artifacts, right? Things like prompts, tooling metadata, vector DBs, et cetera, et cetera. So there's a couple new changes in paradigms, but not foundational changes in the areas. Things that are still true and that are more emphasized is that the boring data is even more important, right? This garbage in, garbage out is more true than ever before. And this requires actually what is now standardization of the interfaces, right? This boring data now needs us to think about how do we actually consume them in a standardized, reproducible way. And we were chatting with one of our distinguished engineers about the MCP architecture. It's actually pretty sophisticated spec, right? So it's actually like something that would be recommended to check out. So now, we also have started to see new emergences of considerations in security, right? With agentic systems, as I said, now we're seeing people doing things in production that normally before you would have said, don't do that, right? But now it's becoming a little bit more of the standard norm. And with that, it has required us to figure out what could be a taxonomy to refer to those vulnerabilities. Things like data poisoning, right? Like putting malicious data on your training data to be able to make a model infer things that would be in the wrong direction. Memory poisoning, remote code execution, identity spoofing, multi-agent chain exploits, et cetera, et cetera. And the interesting thing and the funny thing is, I don't know if you remember back in the day where SQL injections were still a thing. You could go into a website and you could see that the query param was basically a direct input to the SQL query without cleaning. So we're starting to go back to that era, right, where you now have basically raw text from users that is just shoved into the systems, and then YOLO'd into seeing what happens next, right? So we have to be also a little bit careful. We need to introduce hygiene, right, when it comes to those type of systems. And really, I mean, it's again, this room that is going to be driving a lot of those capabilities. So that is, one of the key things to remember as well. And maybe just, as a very high level, there's also a bit of an emergence on the agentic stack. So I'm not going to cover it in a lot of detail because this in itself is probably a talk in itself. But this involves a lot of different new components and basically a new emerging stack. What that means is that we've kicked off another area of messy innovation. And we are seeing, and we're going to continue seeing, a crazy amount of many tools that are kind of doing the same thing but slightly different, right? This is back in the day when we didn't know Mesosphere, Kubernetes, which was going to win, right? But now it's kind of like retrospectively obvious, right? But we're kind of like in that stage, right? So this includes different components like the agentic orchestration, the MCP tools, the guardrails themselves, the gateways, right? There's actually like intricacies of the gateways themselves, the orchestration of the models, the hardware scheduling, the observability, and the security, right? So again, we're not going to dive into much detail, but this is just kind of like a high-level taxonomy of this. There are still limitations. So we are today in 2025, right? As I said, my prediction was back in 2015 that everything was going to be sorted by then. We ran a survey. We ran a survey last year on the state of machine learning operations, and we found some interesting results. We are also running the survey this year, and we would actually benefit a lot from your input. So if you have time, please give us your perspective. One of the things that we actually found was that when it comes to real-time model serving, this is an area where almost 60% are still using custom Python wrapped code, right? So this basically means different APIs, often without open API schemas, different paths, unstandardized behaviors, and just a bit of a wild, wild west, right? And this is actually pretty crazy, right? The fact that I've also been working on specifically just ML inference for already quite a lot of that decade, that this field is still not there yet. And even more scary than that, for machine learning monitoring, it turned out that over 50% don't have monitoring for the machine learning production, right? So this is actually emphasizing how far we still are as a field. So because of that, now standing in 2025, what we want to do now is take a peek into the next 10 years, right? And see what are some bets that we can make that, maybe we'll stand here in 2035 and see if we were right. Obviously, one thing that I will do is I will be a little bit more cautious with my predictions, right? Because I was a little bit too ambitious previously. So with that, let's go for today, right? So obviously, we covered where we are today. And I broke it down into basically 2028, 2030, or 27, 30, 33, 35, right? So 27, I have different probabilities, right? Red, amber, green. I would say by 2027, most organizations will have hired their, MLOps engineers. Everyone has at least one personal agent, right? There's a unified standard for monitoring that emerges, and LLMOps heterogeneity of the stack peaks, right? So there's still 2 more years of this, right? Still 2 more years of this noise. Median time to production decreases. The survey basically said that it's 3 to 6 months today. So my bet is that decreases to a month. I mean, I should have put this yellow. On the monitoring side, I do want to give a shout out to OpenTelemetry, right? Because I would say that some of these folk are the ones that are going to help us get a little bit at least closer to that, right? And this is more or less the type of kind of direction that I'm looking at. Then 2030, I call it this LLMOps unifies. So I would say most organizations already have a central ML platform, build versus buy, right? It doesn't have to be actually like build. Inference subsidies stop, right? Today, if you run a chat request, you're being heavily subsidized. OpenAI, Anthropic pays a significant percentage of your tokens, right? At some point, that will stop, right? And one could say maybe the cost decreases by then, maybe not, and maybe it is so critical that we actually have to pay the bill. We need to remember this, right? That's my bet, 2030. It probably happens earlier. MLOps and LLMOps stacks finally align, yes, until 2030. And ML monitoring becomes ubiquitous, right? So analogous to SRE. I'm actually not confident of that, but I really hope that's the case. Otherwise, it's a pretty scary future if we actually live on this AI world where we don't have monitoring, right? That's crazy. So median time to production decreases to less than a week. Again, low confidence. Then the next stage is operation for autonomous systems, right? Intelligent progressive rollouts, right? So this is where we start seeing a glimpse of self-healing systems, right? Some people may say, oh no, we're gonna have that next year. look, if we don't have an aligned MLOps and LLM ops stack, I mean, how are we going to do that, right? I mean, we can't get the foundations. I mean, maybe I'm going to get surprised. Maybe this time I'm wrong, right? And you know, it comes faster. That would be great. But, you know, I think 2033. Root cause analysis and sys optimization, you know, starts being done by agents. And we start transitioning from LLM ops to autonomous systems ops, whatever that's called. So a new stack emerges, right? So a new bubble, a new era of hype, figuring out what is going on, right? And then 2035, my bets are that now self-healing systems are commoditized, right? I would say even, you know, the domain in this room, the role of an SRE, goes into the next level of abstraction, whatever that means, right? More strategic, more, I don't know, you're going to wear like advanced Googles and press buttons in the air, right? I mean, I don't know how that's going to work. But that's kind of like, you know, when I see that commoditizing, after that bubble kind of like, you know, increases. Autonomous rollouts begin to reach mass, so most organizations are basically just like, you know, producing reliable resources from that. Even maybe new programming languages emerge, right, that actually like abstract some of those higher level concepts. And finally, we start seeing some of those GPU inference costs optimized. Again, red. And then medium time to prod decreases, analogous to software today, to multiple deploys per day, right? I mean, that would be interesting because that would also require us to think about how to do A/B testing and decrease it to that level of extent, right? But I mean, maybe it could be possible, right? Oh, and also still waiting for AGI, right? I mean, I don't really, you know, I'm not a big believer that Skynet is coming, you know, anytime soon. Especially with the current state of MLOps. I mean, can Skynet really run on the current state of inference? No. So that's basically some of the predictions. And with that, let's actually now reflect, right? So that's a lot to really think about. Let's maybe like crunch some of that stuff. And I want to leave some takeaways, right? So we did talk about like all of these considerations, but not everybody is Google, right? And even Google, not every team is Google Maps, right? When you have a lower amount of complexity, you also need a lower amount of complexity, right? You don't need a significant Kubernetes stack with 400 microservices. You can just start, indeed, with a Jupyter notebook, just with the scientists, and being able to just enable that velocity, right? Obviously, as you start reaching mass, as you start seeing more science pop up, more use cases emerge, then you can benefit from starting to introduce some more capabilities, right? This can be in the concept of MLOps, machine learning engineers that are enabling this productionization, right? And as you start having, again, more models, more organizational complexity, then that's when you actually start thinking of having your platform engineers, your MLOps engineers, and you start actually going into the spectrum of more automation, more standardization, control, security, observability, et cetera, et cetera. So this is actually very important, right? It doesn't require for you to like spin up a massive complex cluster from day zero. Similarly, another topic that I want to talk about, and this is analogous to the predictions and where I'm coming from, is I want to talk a little bit about not just, you know, engineering for Gen AI or ML, but ML or Gen AI for engineering, right? And where we are with that. So in terms of the development funnel, let's think about it in a simple way. First, you have the code, test, operate, monitor, right? When it comes to AI tooling as of today, we have a lot of copilots that are focused at the beginning of the funnel, right? And unhappy humans at the end, because there's not really much maturity down the area. What do we like? We also like coding, you know, and giving it to AI. I mean, we don't want to just be code reviewers. I mean, although, you know, we already kind of are, right? YAML reviewers, you know. But yeah, but then looking at the Gen AI tools that are out there, there is a significant amount of tools on the top of the funnel, right? And what we see in organizations that is interesting is that we see a lot of claims for increasing productivity, right? And we see a lot of contrasting views, right? But with those claims of increasing productivity, we do see perhaps there is a small increase in individual productivity, but we haven't yet seen results lower down the funnel. We haven't seen increasing deploys, we haven't seen increasing applications, increasing value, increasing blah, blah, right? And this goes back into some of the tooling as well, right? So we're seeing that also as you go down the funnel, the maturity and the number of tools decreases significantly, right? So whereas at the first one, you have things like Claude and Copilot and etc., then you go into the testing QA, you have a bit less, right? And they're a little bit less sophisticated, things like CodeRabbit for PR reviews. As an open source contributor, like, who likes to have an AI PR? I mean, I really dislike when, especially when it's somebody that just like Claude code and just submitted it, right? It's like, okay, this is clearly AI, right? Then you go into the operation, right? Here it becomes even more shallow, right? It's actually just what is it, like chatbots that generate some CloudFormation, templates, right? I mean, is that gonna automate all the developers? I don't think so, right? And then at the end, there's actually some interesting ones there. I mean, I have to say, there's actually some interesting there, and but they're still not there yet, right? And this is where we need to really emphasize: if we do want to get to this ambitious, futuristic cycle, the things that we need are, number one, the foundation, and number two, to start really investing in the lower parts of the funnel, right? The parts that we do want to really kind of be able to raise the level of abstraction from that perspective. So, and then we have happy humans, right? So that's what we want to do. Good, and then the final topic, just to close, this is how I want us to also think about the challenge, right? And how we've gone through this 10-year journey, right? So we started basically with low scale, low complexity, a small number of tools, and then we went through this messy innovation, right? And we reached the next level of scale, right? However, we took a significant amount of tech debt, we took a significant amount of complexity, and this is something that now for the next stage, right, for the next 10 years, what we need to focus on is to get to the next level of scale, but actually also reduce that level of complexity, right? And this is definitely something that, I very much see will be quite key, done together from the people in this room. So if you're curious on other resources, I added a couple in the links here. So these are other talks that I've given throughout the years. I actually have to update a few of them. I'll put like the state of MLOps from last year and the year before. And you can find the slides on the corner, right on the corner. So that's like a bit.ly link. So that's where you will find also all the references at the bottom of the slides. And as I mentioned also, it will be great if you can help us with your response on the State of MLOps survey for 2025. So with that, I appreciate it, and that was the journey to the past and the future. Thank you very much.